we're making a cross section, you can kind of think of it like taking a cheese slicer or a knife, and we're going to take our 3D shape and we're going to just slice directly in a straight line through that shape to see what happens. And what happens is if you were able to take apart the two halves or the two pieces of the 3D shape, you would see a two-dimensional shape in the middle. So I know it sounds more complicated than it really is. You can think of like slicing bread or something like that, how when you slice it, if you look at the flat side, you'll see a shape. So we call that a cross section. And for any given 3D shape, if it's a right cylinder or a right cone or just like one of those predictable kind of shapes, we can also predict what types of cross sections are available for that shape. So the first one we're looking at here is a cylinder. And the three types of cross sections that we're really going to focus on are a horizontal cross section. That's when we cut across horizontally. Vertical cross section, which is when we go straight up and down, or diagonal, just to see what happens. Now, for a cylinder, if you cut directly across, what you're doing is you're replicating the base. And since the base is a circle, your cross section is also going to be a circle. If you tilt that, though, you're not going to get a perfect circle. You're going to get something that looks more like an oval. And you'll see more of those when you get into Algebra 2. And if I cut directly vertical, because we are going to have two straight lines on either side and then parallel lines on the opposite sides, you end up with a perfect rectangle. So I have a question for you over here. What would have to be true to have a square cross-section of a cylinder? So if you think about it, this is going to be related to the rectangle. So this is going to have to be a vertical cross-section. And in order for it to be perfectly square, wherever you cut it, the width of that rectangle will have to be exactly the same as the height of the entire cylinder. So just kind of a fun mental exercise is trying to figure out what different types of shapes are possible and what happens when we move that cross-section plane around. So here are some other options you might see. We'll be talking about cones and rectangular pyramids. And cones are actually rather special. In Algebra 2, you're going to see a lot of different cross-sections of cones because they follow very interesting formulas. But for our purposes, we're just going to be identifying what shape they are. So if it's exactly parallel to the base, then it should be the same shape as the base. And since the base of our cone is a circle, parallel to the base will also produce a circular cross-section. Similar for a rectangular pyramid, if you look over on the right, if we make a cross-section that's exactly horizontal, it should create a shape that is the same as the base. So in this case, we have a square pyramid, but if you had a rectangular one, it would make a rectangular cross-section. Now, interestingly, a cone and a pyramid both have the same vertical cross-section if you're going right through that top vertex. The top vertex causes it to have a point at the top, and since they're both flat on the bottom and have two angled sides, you end up with a triangular cross-section for our vertical one. But think about it, if you moved that vertical slice over a little bit, would you get a different image? And since a cone and a pyramid obviously are very different shapes, you can imagine that they would probably have slightly different cross-sections. And that is true. If you move a little bit further over on a cone, you still have a flat base and you still have some point where they vanish into the sky, and it still makes a triangle. But if you're over here on the rectangular pyramid, the base where it cuts across here is not going to necessarily come to a point up above. So we're going to see this one on the next one. So if you think you know what shape that is, let's test your theory. So I'm going to tell you that this is a square based pyramid, which means that the base of it is exactly a square. So what shape did you guess was the cross-section? If you guessed trapezoid, you are correct. We have two parallel sides, the top and the bottom. And because it angles from here to the outside, and then same on the other, it forms a shape that looks like that if you were looking at it more straight on. What type of cross-section was this? This is a vertical cross-section because we're slicing from top to bottom. Now, the other topic we're going to be covering in class is spheres. And a sphere is like you take a circle and you spin it around a center point. And every point on this sphere is exactly the same distance to that center. And it forms kind of a ball type shape. And each of those points is exactly one radius away from the center. A sphere has new formulas for you. So volume and surface area formulas are right here. And there's a reason we haven't talked about spheres yet in our ventures with 3D shapes, and that's because they don't follow almost any of the rules as all of the other ones. You can't really easily flatten out a sphere, which is why maps are so difficult to create. And it's obviously not a polyhedron because it's very, very curvy. So a lot of the things that we've been practicing so far just don't apply. And if you want to get really into spheres, you got to keep going higher and higher up in math because they get pretty interesting. All right, that's it for today. See you in class.